The borders in Europe were abandoned years ago. Growing steadily as of 2007, the European Union consists of as many as 27 member countries and 3 candidate states. Consequently, tackling issues internationally in every field is becoming increasingly important. Nowadays, people sooner and more easily take the car, train or plane, and often travel greater distances for work or going on holiday. The open market this has created ensures greater competition, which requires lowering costs on many fronts.
Door de vorming van Europa wordt mobiliteit steeds internationaler. Dus niet meer alleen mobiliteit binnen Nederland, maar vooral ook mobiliteit over de grenzen heen. En het geldt zowel voor personenvervoer als voor goederenvervoer. Dat zal internationaal enorm toenemen. Er is een grootschalige Europese ontwikkeling op gang gekomen naar een trans-Europees railnetwerk. De bedoeling van het netwerk is om op Europees niveau corridors te vormen. Dat wil zeggen gegarandeerde vertrek- en aankomsttijden voor zowel personenvervoer als goederenvervoer. En dan natuurlijk met begin- en eindpunten in heel Europa. De bedoeling van het netwerk is om de concurrentie aan te gaan met vrachtverkeer, luchtvaart en binnenvaart. ProRail is van begin af aan betrokken geweest bij de totstandkoming van de Europese standaard voor het beveiligingssysteem. Doet dat tot op de dag van vandaag en zal dat ook in de toekomst nadrukkelijk blijven doen.
Whereas the car or plane can effortlessly cross several countries, this is still a challenge for rail traffic. A train cannot simply travel from one country to the other because many countries have their own safety system and apply different traction voltages. If, for instance, we look at the situation at the Dutch-German border, we see that a Dutch train has to stop at the first station after the border. Here, the Dutch locomotive has to be uncoupled to make way for a German locomotive waiting at the station. Once it has been coupled, the train can continue on the German network. The Dutch locomotive remains behind and will be coupled to a German train to return to the Netherlands. A different solution to this problem could be to equip every international train with all kinds of national systems. The Thalys, for example, travelling from Amsterdam to Paris, has been fitted with 7 safety systems. Given there are more than 10 different safety systems in use in Europe, this would be much too expensive and an impractical solution for most international trains. Traffic on the rail network is intensifying. Both the number of trains and the speeds allowed are constantly increasing, resulting in increasingly stricter safety demands. As a consequence, various European rail infrastructure managers joined forces a number of years ago and started the development of a single standardized solution for the whole of Europe: the European Rail Traffic Management System, ERTMS. In the Netherlands, more than 1 million people travel by train daily. Passenger transport adheres as much as possible to a fixed plan. Passenger trains, therefore, have fixed departure and arrival times every day. Besides this, considerable freight transport takes place by rail, which demands flexible assignment of the available track capacity. Rail traffic control is also a planned and safety-relevant process, organized from various control centers throughout the country. From the rail traffic control centers, the train dispatchers for every train movement ensure the availability of safe infrastructure such as switches, level crossings and bridges. If the desired route is secured, the green departure signal can be illuminated. Luckily, this doesn't all have to be done manually. Thanks to ARI, automatic route control, all the known train journeys are prepared and carried out at the right time. A train driver is trained to drive various types of trains and travels every day on different routes. Before a train can be driven, the train driver's job is to ensure it is ready to depart. As soon as this is the case, he checks if the departure signal is at green and the train has permission to leave. If all goes according to plan, there's no need for extra communication with the train dispatcher. Should communication be required, the train driver has telerail at his disposal, a direct radio connection with the train dispatcher. At present, the track is divided into fixed block sections. The start of such a block is marked by an illuminated signal. The section length varies from block to block. On an open line, for example, it is 1,500 meters, but at busy junctions, such as a station, it's much shorter. The process of setting routes across the various sections is constantly monitored and controlled by the safety system. If not all conditions for authorizations are met, for example because a train occupies one of the block sections, the route is not set. The signal granting permission to enter this block then automatically stays at red. In the preceding block, the signal will be yellow. A train driver who passes this yellow signal will activate the train's braking system and has sufficient time to bring his train to a halt before the subsequent signal at red. In this way, trains always maintain a safe distance from each other. If it is established the situation is again safe, the signal changes to green and the train can continue its journey. The train driver, therefore, drives in fact from block to block, and based on the signals, checks every time whether the next block is free to enter. Most of the trains in the Netherlands are fitted with ATB, in English, Automatic Train Protection, or ATP. This system monitors the train's speed and is activated when necessary. The ATP equipment on board constantly receives information about the maximum permitted speed the train may travel at that time. If this speed is exceeded, the system warns the train driver to brake. When he doesn't brake or brakes insufficiently, the ATP kicks in and braking is then activated. However, ATP has a number of important limitations. There is no speed monitoring if the train is moving at less than 40 kilometers per hour. As a result, slow-moving trains can, without hindrance, pass a signal at red, which can result in dangerous situations. With the introduction of an increasing number of high-speed trajectories throughout Europe, the present safety system imposes another significant limitation. At speeds up to 160 kilometers per hour, the train driver is well able to interpret wayside signals. With high-speed trains, however, speeds can reach 300 kilometers per hour. As a result, it's almost impossible for a train driver to interpret the signals along the track properly in time. Bad weather can also make it considerably more difficult to interpret signals. Driving at these high speeds requires a system that presents the signal information inside the cabin. The development and introduction of ERTMS are processes already far advanced at a European level. All the European countries cooperating on this gradual changeover have the same goals. The primary aim of ERTMS is the advancement of interoperability. In other words, making it possible for international trains to cross borders without hindrance. Besides this, ERTMS must enable travelling at very high speeds. Fixed signals along the track will no longer be adequate, but providing the required information to the train driver on his screen in the cabin will make this possible. Finally, safety will be improved, given that ERTMS also monitors the speed if it is below 40 kilometers per hour. Consequently, passing a signal at red is almost impossible. Most countries have a number of main lines for transporting passengers and freight. However, these do not always connect with the main lines of neighbouring countries. At present, a lot of hard work is being done in various countries to connect the most important lines with each other, thus creating European corridors. Two examples of this, which we'll come back to later, are the high-speed line south connecting Amsterdam to Paris and the Betuwe route, which connects the port of Rotterdam with Milan and Genoa.
Deze lijnen moeten openstaan voor meerdere vervoerders om een optimale benutting van de capaciteit mogelijk te maken. Daarnaast hebben we toepassing nodig van ERTMS, de standaard voor het Europese beveiligingssysteem, om soepel treinenverkeer over heel Europa heen mogelijk te maken. U zult begrijpen dat we daarvoor de samenwerking nodig hebben van alle betrokken partijen in Europa. En ProRail is een van de duidelijk actieve partijen in dat hele spel. ERTMS wordt geleidelijk ingevoerd. In Europa wordt ERTMS al toegepast in Zwitserland en bijvoorbeeld op de lijn Rome-Napels. Als ProRail starten we met de invoering van ERTMS op de Betuwe-route, de HSL en op het traject Amsterdam-Utrecht.
The High-Speed Line South is the Dutch section of a European network of high-speed lines. This line connects with the high-speed lines in Belgium and France. When everything is ready, people will be able to travel comfortably and quickly from Amsterdam via Rotterdam to Antwerp, Brussels and Paris, and via the Channel Tunnel even to London. With the arrival of the high-speed train, the travel time between Amsterdam and Paris will be shortened by an hour. Ultimately, speeds on this line could reach 300 kilometers per hour. The Betuwe route will provide a fast direct freight rail connection between the port of Rotterdam and Germany. This line is destined to be the artery for all Dutch freight transport. With the realization of this fast and safe trajectory, the increasing stream of freight from the world port of Rotterdam can quickly reach the European heartland. It will result in a considerable reduction of truck traffic on the road. After crossing the German border, the train can simply continue on to, for example, Switzerland and Milan. Finally, on behalf of ProRail, large-scale reconstruction of the track has taken place on the Amsterdam-Utrecht trajectory. The track has been doubled over its total length. The Utrecht Curve flyover is constructed north of the Amsterdam Arena Stadium at Ouder Amstel. This 15-meter-high and 1,800-meter-long rail bridge connects the existing Schiphol line with the Amsterdam-Utrecht trajectory. As a result, a fast direct train connection is established between Utrecht, Amsterdam South WTC and Schiphol. The development of ERTMS stimulates a free market. For the Netherlands, this means not just one, but several suppliers are able to deliver an ERTMS safety system. In this startup phase, Siemens supplies the safety system for the high-speed line south, Alstom for the Betuwe route, and Bombardier for the Amsterdam-Utrecht trajectory. As the first in Europe, the Netherlands has demonstrated ERTMS trains from these three suppliers can run successfully on the same test track. An important step towards the actual introduction of interoperability throughout Europe. The introduction of ERTMS is not carried out in isolation, but as part of 4 interrelated innovation projects which are being introduced. Instead of a conventional safety system, a system is being applied that meets all the ERTMS European specifications. The existing rail traffic control system, through which routes are set, is being adapted to be able to interface with the ERTMS system. At the moment, a national GSM network is being installed, which besides voice traffic is also able to transmit data from the ERTMS system between the wayside and the train. Where the track use requires it, a traction voltage of 25 kV is being applied. For example, this is the case with very high speeds on the HSL line and with the high power that large freight trains require on the Betuwe route. The ERTMS safety system consists of a combination of two important elements. First, the European Train Control System, or ETCS, the part of the safety system on board the train. Besides this, the use of GSM-R, an extended GSM network especially for rail traffic. Each ERTMS train has a European Vital Computer, part of the ETCS. This is where the data about the route, composition of the train, the permitted speed, and the train's location are processed. The train dispatcher requests a route from the system. The system checks if this request can be safely granted, and if so, sends a movement authority to the train. This data is processed by the computer and, via the cabin display, passed on to the train driver. The information is constantly updated during the entire journey. If, for instance, the train's speed threatens to exceed the maximum permitted speed, the system automatically warns the train driver. If the driver does not act correctly, the ETCS forces the train to a standstill. The two most important ERTMS system levels are indicated by Level 1 and Level 2. Before we explain Level 1, let's first look at the current situation, which uses ATP. The train dispatcher must set a route for every train movement. This data is then sent by a fixed cable connection to the signal. An ATP code signal is conveyed to the rails. Whenever a train rides over it, this ATP code is picked up by a number of spools under the train. In the cabin, the train driver sees the permitted speed. ERTMS Level 1 is very similar to the current situation, except there is a special beacon between the rails at each signal. The so-called balise, an electronic beacon, is permanently coupled to the signal. When the train dispatcher sets a route, the train driver can not only recognize it because of the signal color, he also sees it on the cabin display. As soon as the train passes this balise, all the important data is transmitted to the receiver under the train, which is then processed by the computer. Based on this data, the EVC monitors whether or not the train is exceeding the permitted speed. The train driver can always call the train dispatcher from the train. There is a radio communication system on board every train in the Netherlands, which uses the GSM-R voice channel. Besides a voice channel, GSM-R also has a data channel. ERTMS Level 2 uses this data channel for conveying all important data. Since the information is no longer sent to the train via a fixed cable connection, it can be passed on to the train's receiver at any desired moment. The train driver now always has the most up-to-date information available to him. As a result, the use of signals along the track is superfluous. There are still electronic beacons between the tracks, but now they mainly are used as reference points for the exact location determination of the train. This location data is transferred from the onboard to the wayside system. Let's list all the items once again. The current ATP system uses fixed connections between the rail traffic control system and the signaling system. The train receives the ATP code via the rails. With ERTMS Level 1, each signal is linked to an electronic beacon which takes care of the transfer of all important data. With ERTMS Level 2, fixed connections are no longer needed. There is a constant exchange of data between the train and wayside via GSMR. With the introduction of ERTMS, initially the sectioning of the track into blocks is maintained. This means little change in terms of operations for the train dispatcher. The allocation of the routes and even the presentation of the status of the signals along the route are displayed almost identically as with the current system. There will be new regulations for both the train driver and the train dispatcher. For the train driver, a few things do change. He will have an ERTMS operating panel or driver machine interface at his disposal. This is the new operating screen, which translates the local operating data to the train driver into clear advice and tasks. By means of the touchscreen, the train driver can access all the necessary information about the trajectory. The interface is constructed of 4 elements: an input menu for the train driver, speed information and braking advice, up-to-date route information, text messages and other information. In the following example, we are driving on an ERTMS Level 2 trajectory. Once the route has been set, authorization is passed on via GSMR to the train. The ERTMS equipment receives the signal and the train driver immediately sees the route on his screen. This situation is similar to a signal changing to green. In this example, we see permission has been granted to depart at a speed of 60 km per hour. There are no signals along the track anymore. On the left, we can see the distance to the next point, after which we can drive at 250 km per hour. As soon as we pass this point, the new information is displayed on the screen. We now approach a trajectory with a speed limitation of 130 km per hour. The system now passes on the speed advice to the train driver. This is shown on the display by means of a yellow braking curve and a yellow speedometer. If the speed reduction is insufficient, this changes to orange and the driver must brake harder until the new speed is achieved. In this way, the train driver sees at a glance all the information he needs, despite bad weather conditions or high speeds. At present, ERTMS levels 1 and 2 are being applied successfully on various trajectories in Europe. More than 15 countries are already using the new safety system. In the Netherlands, a number of trajectories have been fitted with ERTMS. The high-speed line south uses level 2. Should the GSMR network ever crash, the system will fall back to level 1. High-speed trains would then have to lower their speed to 160 km per hour. The first full ERTMS Level 2 application in the Netherlands is the Betuwe route. This 160 km long rail freight connection has a capacity of 10 trains per hour in each direction. The Amsterdam-Utrecht trajectory is one of the busiest travel trajectories in the Netherlands. But, as it would be a huge investment for transporters to equip all trains with both the ATP safety system and ETCS, this route section will still use ATP. On top of this, the trajectory will also be fitted with ERTMS Level 2. And because this involves a double safety system, we call it a dual or mixed signaling trajectory. Many international train operating companies are aware of the advantages of ERTMS, which is why this safety system is being applied successfully to an increasing number of trajectories in Europe.
ProRail draagt door de invoering van ERTMS bij aan een soepel lopend en veilig Europees railnetwerk.